This is composite area. So now what we're talking about is taking two shapes and usually putting them together in some form or fashion. The shaded area is what we're always trying to find. We're trying to figure out the shaded parts, and the white is like taking that out or like cutting that out of the shape. So what I tell kids to do is just start with a visual. Tell me the two shapes that you have, or more if you have more than two shapes. And we're going to start with like the most outside shape that we have. So we have a rectangle. And since this space is white, that means we're going to be subtracting it out, and we're going to be subtracting out a triangle. The formula for a rectangle is base times height. The formula for a triangle is 1/2 base times height. So just focusing on the rectangle, do we have our base and our height? We do. We have a 21 and a 34. Minus 1/2. Now I need the base and height of the triangle. So this triangle has a height of 16. I don't know its base. And then this side is actually the same as this. So this is a 34. But when you do base and height of a triangle, they need to share the 90-degree angle. So if you're going to use this as your height, we need this base, which means we're going to do a quick Pythagoras theorem. So here's a 16 and a 34. Here's my 90, and we need to find that. So 34 squared equals 16 squared and an x squared. So 34 squared, we're going to minus the 16 squared over, and then we would square root 900. So our x side is going to be 30. So our base is 30 and our height is 16. And now I can just type all that in. And I get 474. This one didn't have any labels, so we'll do units squared. Next picture, I've got a rectangle on the outside, and we are taking out a circle. So the formula for a rectangle is base times height. A circle is pi r squared. So base and height of the square are 10 and 10 minus pi, and then r squared. So we need this distance right here, just the radius. So the whole thing, the diameter actually is 10, so half of that would be 5. 10 times 10 is 100, and then we're going to minus pi 5 squared. So we get about 21.46. Again, no labels. Sorry about that. Units squared. Next, I've got like a bullseye picture. So remember, we want the shaded parts. Start from the outside. So the outside is a circle, and then we're going to subtract the inside circle, and then we're going to have to add back in this shaded circle. So when you subtract out this white one, it actually subtracts out this whole space, not just that ring. So then we have to add back in this little, the center circle of the bullseye. And this line is pointing, saying that each of these is worth 3. So 3, 6, 9. So pi r squared minus a pi r squared plus a pi r squared. Kind of weird. So we're going after the big circle first. So the radius of the big circle is 9. Then we're going to minus off like the second circle or the medium circle, and that would have a radius of 6. And then we have to add back in the smallest one, which just has a radius of 3. And we literally just get to type that in. So pi 9 squared minus pi 6 squared plus pi 3 squared. About 169.65. This one has a label, so feet squared. Kind of hard to tell on here. It should be better in your notes packet, but this was the shaded part. So focus on the shaded part as being the overall shape. That's a parallelogram. And then we're taking out a kite. Parallelogram is just base times height. A kite is 1/2, and then it's diagonal times diagonal. So base and height of our parallelogram, that's a 12 and a 7. That's pretty straightforward. Oops, minus, not equals. 1/2, and then I need both of my diagonals. This is the first diagonal, which happens to be the same as 7. This is the second diagonal, which happens to be the same as 12. So not much to figure out on that one, just recognizing that whatever measure you have down here is the same measure horizontally all the way up to the top. So we've got 12 times 7 minus then 0.5 times 7 times 12. Let's get about 42, no labels, so units squared. Two more. This one, there's no white part, which means we are putting these two together. So I have a triangle and I have half of a circle. So triangle is 1/2 base times height and a half of a circle, so pi r squared. Base and height of my triangle looks to be 7 and 7. Radius of my circle, 7 is the diameter, so radius would just be 3.5, half of that. So half of 7 times 7 plus half of pi times 3.5 squared. So about 43.74. And labels here, so meters squared. One more. We've been doing this kind with the polygons. So we've got on the outside, we've got a circle, and then we are going to minus and this is a 6 side, so a hexagon. So circle is pi r squared, and we're going to minus a 1/2 ANS. So pi, radius is 5, minus 1/2, and then we need ANS. So I don't know apothem yet. Number of sides are 6. Side length, I don't know either. So off to the side, I'm just going to bring this triangle right here. Just make it a little bit bigger so I can write on it. That 5 was to the radius, so that's right there, which means we need that angle. So remember, central angles, we just do 360 divided by how many sides we have. And then we just divide that in half. So this angle is a 30. I need to know this side, which is the apothem, and then I need this side. I'm going to make this be an S, so make sure that you draw yours like a nice S. That's going to be part of our side length. So first I'm going to do apothem, so that's adjacent and hypotenuse. It's going to be cosine 30 equals adjacent and hypotenuse, so 5 cosine 30, about 4.3. That's my apothem. My side length is going to be opposite and hypotenuse, so that'll be sine of 30 equals, and that's an S over 5. So 5 sine of 30. It looks like my side, this right here is 2.5, and remember you have to double that because it's only half of your side length. So when you find that S or that bottom edge, you need to double it. So now I've got 0.5 times the 4.33 and times 6 and times 5. So it looks like we're looking at about 64.95. No labels, so we'll just do units squared. And those are composite areas, just putting together or taking away different areas of shapes.